Okay, today we are going to figure out what is the pH of a 0.0250 molar NH3 solution. NH3 is a weak base, which is why we have a Kb value. Okay, so the first thing we're going to do is check the assumption. So with acids, it was the molarity of the acid divided by Ka needed to be bigger than 100. It's completely analogous for bases. The concentration of Kb concentration of the base divided by Kb needs to be bigger than 100. So plug this in, see what happens. 0.0250 divided by 1.8 e to the negative 5. And I've got a value of 1390 basically, which is well over 100, so that means we don't have to use the quadratic. Okay, which should make our lives easier. The rest of the problem is still the same. The main difference is that because it's a base, we're gonna have to solve for POH first. So because it is a base, our balanced equation is going to be NH3 dissolved in water, which is the reaction that Kb is describing. In equilibrium, this is a base, so it's going to receive an H plus from this, which is going to act as an acid. Water is inherently neutral. It kind of depends on whether it's in the presence of an acid or a base. So basically this will receive an H plus and become NH4 plus, which is the conjugate acid. And then this is going to lose an H plus, which makes it an OH minus, which is why this is a base. Okay, so this is the conjugate base. Okay, so the ice method. The rest of this will look really similar, except that we're solving for concentration of OH instead of concentration of H3O plus. So this is 0.0250. We're going to ignore this. This is 0 and 0. This is going to decrease by some amount. Everything's got a 1 in the front, so for every 1 mole of this, we'll get a mole of this and a mole of this. So equilibrium is 0.0250 minus x, and that's x and x. So the reason we did that is that Kb is equal to the concentration of NH4 plus times concentration of OH minus. We can ignore the water, but we have all those values. So Kb is 1.8 times 10 to the negative 5th. This side, products over reactants, so these are both x's, so I'm just going to write it as x squared. And then this, because the assumption is true, we instead of writing 0.0250 minus x, we can just write 0.0250. Okay, that only is allowed because our assumption was bigger than 100. Everything worked. So to solve for this, we're going to multiply this to the other side and solve for x. So x is equal to the square root of those two numbers multiplied together. Which we'll find out what the answer is. Okay, so square root 0.0250 times 1.8 e to the minus 5th. And I got 6.708 times 10 to the negative 4th. Okay, this x is the molarity of OH minus, so the units are molarity. And because it is OH minus, we can solve for POH. We don't get to keep that many sig figs, but I'm just kind of keeping more than I need just until we round at the end. So essentially we take the negative log of our previous answer. And I got 3.17. Okay, that is the POH. Our question asks, what is the pH? So to get pH, we're going to take 14.00 minus 3.17, because pH plus pOH equals 14.00. So 14.00 minus our answer comes out to 10.83. Which hopefully makes sense because this is a base producing OH minus, which means its pH should be above 7. No quadratic because the assumption worked. Not much worse than the acid problems. The only real difference is this last step of having to subtract it from pH, or subtract it from 14 to get pH.